Hello everyone, this is Navneeta. Now we are going to study the topic from sound. That is, relation between intensity of sound. So the aim of this topic to know the relation between the intensity of sound produced by a body and the vibrations of the body. Yes, relation between the intensity of sound produced by a body and the vibrations of the body. So for this we need some materials. Those are wooden block, 30 centimeter metal scale or nearly 30 centimeter hacksaw blade and a brick. Yes. Now, first of all, place the blade or scale on the table. Yes. With 10 centimeters of the table on the surface of the table and rest of it in air. Yes, we are keeping the 10 centimeter of the blade on the surface of the table and the remaining part is in air. So keep a heavy brick on one end of the 10 centimeter blade or scale kept on table. So you can see in this slide, the heavy brick is kept on the 10 centimeter blade or scale. The remaining part of the scale is in air. Yes, now vibrate the blade gently and observe the vibrations and simultaneously listen to the sounds. We have to repeat the same for 2 to 3 times and we have to record our observations. Now, vibrate the blade using greater force. Observe the vibrations and listen to the sound. Yes, now repeat this for 2 to 3 times and record your observations. Yes, now here is one table. When we are applying small force on the blade and when we are applying the large force on the blade, we have to note the vibrations of the blade or scale and the intensity of sound. So when we are applying a small force on the blade or scale, so the vibrations of the blade or scale, we can say that approximately 50. So the intensity of sound less, because we are applying the small force on the blade or scale. If you are applying the large vibrations on the scale or blade, large force, so at that time we will observe the vibrations of the blade or scale 50. What is the intensity of sound? Here it is more. Yes. So when do you hear a loud sound? So here, when we applied large force, we heard a loud sound. Yes, when do you hear a loud sound? When we applied large force, we hear a loud sound. And next, when do you hear a feeble sound? So when we applied less force, we hear a feeble sound. So what differences do you notice? Yes. So what differences do you notice in the vibrations of blade or scale during loud and feeble sounds? So here, during loud sound, the amplitudes of vibrations is more. During loud sound, the amplitudes of vibrations is more, and for feeble sound the amplitude is less. Yes? Now, here the initial position of the scale at rest along the surface of the table is called mean position. So the initial position of the scale at rest along the surface of the table. Yes, so we can say that mean position, that is. Yes, so now here OA is a mean position. Here from point O to A, this is a mean position, and OB and OC are the vibrations occurring in the body. Here OA we are considering as the mean position of this vibrating body, and OB and OC are the vibrations occurring in the body. Yes, here the to and fro motion of a body from its mean position, the to and fro motion of a body is known as one vibration. So the body vibrates from the mean position OA to OC. Yes, here this scale vibrates from the mean position OA to OC. Yes, and comes back to OA, and then moves from OA to OB and comes back. So here the maximum displacement of vibrating body from its mean position is called amplitude. Yes, the maximum displacement of vibrating body from its mean position is called amplitude. So here given the maximum displacement is A to B or A to C. So now, what difference do you find in the amplitude of vibration for a feeble and a loud sound in this experiment? Yes, what difference do you find in the amplitude of vibration for a feeble and a loud sound? So here, for a loud sound, the amplitude is more, and for feeble sound the amplitude is less. Yes, for a loud sound the amplitude is more, and for a feeble sound the amplitude is less. So this is a relation between the intensity of sound produced by a body and the vibrations of the body.